All right, happy Friday to you and welcome to your video lesson for today. Sorry that I can't be with you, but I will see you on Monday. Opening question for today, the most important question you'll answer all day. Chocolate, vanilla, or twist for your cone? I'm going to go twist, a little bit of both worlds. Okay, moving on here. Here's what our calendar looks like coming up. So this week we're living in this top row here. Today we're talking about acids and bases, neutralization reactions, and you're going to have an acid-base worksheet. Next week you have a quiz on 7.2 and 7.3 on Monday. Tuesday is study guide, and then we have half days ending at 11:42 on both Wednesday and Thursday when you take your Unit 7 test. Today the plan is to take some notes via this video, and then you'll have an acid-base worksheet that you should have picked up from outside my door. When you come back on Monday, I'll have your quizzes from this past week with me to give to you so that you can check them and make some corrections. All right, starting on page 61 here, the essential question for today is what is so special about acids and bases? Acids and bases are special kinds of solutions. Anything that is not an acid or a base is called neutral. You should have found in your lab on block day this week that an acid always starts with a hydrogen ion, so H+, and a base always ends with a hydroxide anion, so OH-. If you need to pause this as you go, please feel free to do so you have time to write stuff down, but I'm going to keep rolling through. Okay, also on page 61, you should show this pH scale. And so in the pH scale, what we have here are some common things. So water is neutral at a pH of 7. Anything higher than a 7 is considered a base, and it always produces OH ions when it's dissolved in water. So anytime you put a base into water, it always is going to let out these OH ions, so OH-, and the formula of the base always ends in OH. An acid is anything with a pH that is less than 7, so 0 through 6. The acid is solutions that produce H+ ions when you put them into water. So when we put them into water, remember that's called dissociation. And so when you dissociate a base, you get OH-. When you dissociate an acid, you're always going to release H+. So acids always start with H, bases always end with OH. I would put some sort of scale in your notes. It doesn't have to be this specific, but these are some common things that have a pH anywhere from 0 to 14. All right, also on page 61 here, we're going to consider LiOH. And so the first thing we're going to do is write a dissociation reaction for it. So I'm going to pick a color that is not on this slide. And so for LiOH, if we're writing a dissociation, it means that we're looking at LiOH. I'm going to find it on my solubility table, and I see that Li and OH are soluble, which means it's aqueous. So we do know that it dissociates, which means it dissociates into Li plus aqueous plus OH minus aqueous. We're looking for acid or base. LiOH is a base exclusively because it ends in OH. That's how we can tell for letter C. What's a possible pH value for LiOH? Well, it's a base, so anything greater than a 7 on the pH scale. If we consider HBr and we write a dissociation for that, HBr on my solubility table is aqueous, breaks up into H+ and Br-. Each of these are aqueous. We know that this is an acid because it starts with H and we're producing our H+ ion. And a possible pH value is going to be anything less than 7 of a pH. Now, what we can do is we can mix our acids and bases together. And so what happens when you mix an acid and a base together is they sort of cancel each other out. And what I mean by that is they neutralize each other. So Li and OH react in a double replacement reaction. We're going to write the molecular equation for it. So we get LiOH, which is aqueous, plus HBr, which is aqueous, When we pull these things into their pieces, Li plus, OH minus, H plus, Br minus. Double replacement reaction means I end up with LiBr, which is aqueous, plus HOH. And if we think a little bit more about what HOH is, it's H2O, which is not aqueous, it's liquid. Remember that aqueous means it's dissolved in water. You can't dissolve water in water. Water also naturally occurs as a liquid, so we use the little L for the phase. So the double replacement reaction from LiOH and HBr gives us LiBr and water. So acids and bases are really similar to other solutions in the sense that we can have a double replacement reaction, but that double replacement reaction is called, oops, sorry, I'm scrolling all over here, a neutralization reaction. So a double replacement reaction that occurs between an acid and a base, this should say products, you can see my spelling error there. The products of that include water and a salt. So if we think back to the example that we just did, the LiBr is a salt, and HOH is the water. What this visual on the screen is showing you is that at a pH of 7, you've got equal amounts of this H plus ion and this OH minus ion in your solution. If you increase towards 14, which is the highest a base can be, the more basic you are, the more OH ion that's present in the solution, and the less H plus ion that's present. If you are acidic, it means you have a lot of H plus ion and less OH ion. So what you would be looking at is that at this spot, most of what you have is H plus, a little bit of what you have is OH. That's how that table works. All right, so our example for a neutralization reaction that we're going to solve here. First, we're going to predict the products. And we're going to decide what's the acid and what's the base. So to start, I have something that starts in hydrogen and ends in hydroxide. That means that this is the acid and this is the base. What is the name for a double replacement reaction between an acid and a base? That is called a neutralization reaction. So it's a fancy term for the double replacement when we're dealing with an acid and a base being mixed together because they neutralize their pH. All right, now I'm going to predict the products. In order to predict the products, I'll change my color here. We're going to find the charges for everything. So we have H plus and SO4 2 minus. We have K plus and OH minus. Potassium is going to get a new partner, is the other negatively charged thing. We get K, dropping across, 2 SO4. On my solubility chart, that is aqueous. And I get HOH, which we said is a liquid, and we can write that as H2O. Phase notations we filled in for the products. The reactants, if we use our table, are also aqueous. Now to write a complete ionic equation, anything that is aqueous breaks apart, which means I can start on the left-hand side and I have H plus aqueous. Notice that I have a subscript of 2 here, meaning I have a coefficient in my net ionic, or my complete ionic. Plus SO4 2 minus aqueous, plus K plus aqueous, plus OH minus aqueous. I produce K plus aqueous. Notice I need a 2. Plus SO4 2 minus aqueous plus water doesn't dissociate, HOH, or you can write it as H2O. I'm noticing that things are unbalanced, so up top I needed to balance. I'm going to come back in here and take a look. I am going to balance my H2O as an HOH because I can balance my hydrogens with my hydrogens and my hydroxides with my hydroxides. So the first thing I see is that my K's are unbalanced, so I have 2. I'm going to put a 2 here. Now I can balance by putting a 2 here. Transferring down, I have 2 H's, 1 SO4. I need 2 in front of my potassium and 2 in front of my hydroxide. On the right-hand side, 2 in front of my potassium, and my water has a 2. Underlining my spectator ions, change my color here. Spectator ions, remember, are things that stay the same on both sides. So K plus, SO4 2 minus, SO4 2 minus. My net ionic equation is everything except my spectator ions, which means 2 H plus aqueous plus 2 OH minus aqueous gives me 2 H2O, or you could write it as 2 HOH. For the remainder of your hour, you're going to complete the acid-base worksheet that you picked up from outside my door. I will add the key to the WAG on Monday. My goal of your flex hour is for you to use your time actually solving it rather than copying the key. I know for some of you that will feel frustrating. I promise I will give it to you. This is due on Monday. Remember, when you come back, we have quizzes on 7.2 molarity and 7.3 acid-base neutralization reactions. Have a fabulous weekend, and I will see you soon.